Okay, let's start off with a question. If we are going to send people and equipment deep into space, say Mars, or even beyond, what kind of engine are we going to use to get them there? Because it should come as no surprise that the type of combustion engines that we use to launch rockets over the Earth's surface and into orbit today aren't going to be ideal for a long-duration flight through space. Our best science fiction writers have had to invent their own ideas of the engine that could power spaceships of the future, like warp drive, hyperdrive, the Holtzman engine. We don't have any of those right now, but what we do have is nuclear power. And trust me, I know that nuclear spaceships sound kind of crazy or dangerous at first, but once you dive into the subject, it becomes pretty clear that nuclear power is the best bet that we have today for making long-duration spaceflight a true reality. So let's talk about why that is. This is a space race. Okay, first things first, let's start off with an idiot's guide to rocket engines. Solid rocket boosters are next to useless in the modern age, so we're going to toss them out completely. Liquid rocket engines are fairly simple in their basic design. You have two tanks, one containing rocket fuel and one containing oxygen. Those two elements are pumped into a combustion chamber and then exploded. The explosion produces exhaust gas that is pushed through a nozzle to accelerate its flow and produce thrust. Our current generation of rocket engines burn good old kerosene as their fuel source. It's not the same stuff you put in a camp lantern. This is a highly refined form of kerosene called RP1. That's what SpaceX uses in their Merlin engine that powers the Falcon 9 and Falcon Heavy. They choose this fuel because it's cheap, energy dense, and stable at room temperature. But it's not an ideal rocket fuel. You see, burning RP1 produces a lot of carbon that coats the engine components in residue, which they call coking. This effect reduces the potential for reusability and increases refurbishing time between flights. The next generation of liquid rocket engines will be powered by liquid methane. The SpaceX Raptor and the Blue Origin before use a combination of liquid methane and liquid oxygen. Methane is an excellent fuel source because it is one of the most abundant chemicals on our planet. This is the same natural gas that powers furnaces and stoves and all kinds of common utilities, so it's very cheap and easy to produce, plus it's a more efficient rocket fuel. Methane-powered engines should benefit from a 20 increase in performance over kerosene. So because of this, we can either carry less fuel, go faster, or go further. This makes it our best bet so far for traveling to destinations like Mars. And because methane is present on the red planet, as well, it's conceivable that we could actually start to produce the rocket fuel on Mars to replenish spaceships and either send them back to Earth or launch them even deeper into outer space. Okay, so now that we know all of that, we can talk about why nuclear is such a great idea for traveling through space. And that's important to set the stage. When it comes to nuclear engines, we are talking about moving through space only when it comes to getting off the ground and overcoming Earth's gravity. A methane engine like the Raptor is going to be the best bet, not only for the safety factor of not spreading radioactive exhaust into the air, but also because nuclear won't offer the kind of explosive thrust that we need to conquer gravity. So let's imagine we have a rocket that is propelled into orbit by a methane-burning first stage booster. The first stage separates and comes back down to the surface. While out in space, the second stage nuclear reactor powers up to fire its own rocket engine. How does that work? A nuclear thermal rocket engine operates using heat generated by nuclear reaction. In this case, we are talking about nuclear fission, which is also referred to as splitting the atom, and those atoms are the element uranium. The nuclear energy of fission would replace the chemical energy of exploding propellants. In the rocket engine design, we still need a working fluid of low molecular weight that will create the exhaust gas that will flow through the nozzle and create thrust. In this case, that will be liquid hydrogen. The hydrogen is fed into the nuclear reactor, where the extreme heat causes that liquid to readily expand into gas, which is then pushed through the nozzle and creates thrust. You might notice that sounds very similar to our liquid rocket engine, right? But since there is no combustion involved with nuclear thermal power, that means we don't have to bring any liquid oxygen with us into space, and that means more room for more fuel, more stuff. This process also makes for a more efficient engine, so we can go farther or faster in the same amount of fuel as a conventional engine. The downside to this system is a fairly low thrust-to-weight ratio. That's why it's not great for the orbital launch phase of the mission. So far, we've got nuclear thermal engines up to a thrust-to-weight ratio of about 7-to-1 compared to our chemical rocket engines are running around a 70-to-1 ratio. Then there's a nuclear electric engine or nuclear ion. In this case, the thermal energy from a nuclear reactor is converted into electrical energy, which can then power an ion thruster. This is a crazy sci-fi sounding thing, but it's actually a type of engine that NASA have been using for a while to send probes into deep space. This is a much more complicated engine than the other two we just talked about, so we're not going to try to get into how exactly it works. This is an idiot's guide. Remember, the basic idea is that the electricity generated by the reactor positively charges a gas propellant like xenon or krypton and pushes the ions out through a thruster which drives the spacecraft forward. This process is super efficient and allows These thrusters to run for months and years out in space. It's like a low and slow kind of engine that only requires around 7 kilowatts or less of electricity to function. And that's why we're able to run these deep space probes off of just a few solar panels. But if we really want to get out into space, then we will hit a point where solar energy diminishes to the point where it doesn't work anymore, and that's why nuclear is inevitable for this application as well. These ion engines are great for long sustained flight, but they lack the thrust necessary to change velocity very quickly. The ion engines that we are using right now require months or even years of constant thrust to reach their top speed, and then they need the same duration of time to slow back down again. So for going to Mars, this wouldn't be ideal on its own, but if we can work out some combined system of nuclear thermal and nuclear ion power engines, then we would have one hell of a spaceship that would get us to Mars both quickly and efficiently. The idea is that by using nuclear energy, we can get the trip time to Mars down from 8 months to just 100 days, and that's very important to making Mars a truly practical destination. For one, we only have a short window of time when we can fly between Earth and Mars, and this window only comes up every 26 months, so we need to get as much accomplished in that time as possible outside of the window. The two planets are going to be separated by the sun, and that's not something we can just fly straight through. For two, we still don't really know what kind of effect that deep space exposure will have on human beings. There's a lot of weird radiation and stuff out there, and the further we get from Earth, the more exposure we get as well. So obviously it would be ideal to keep that to minimum until we have a better idea of what's going on. So that all sounds great, but how close are we to actually making this happen? And is it even safe? We're talking about turning a nuclear reactor into a rocket engine. Well, this is an idea that has been contemplated since the dawn of the nuclear age. Back in the 1940s, NASA started exploring the concept in the 1960s when it was working with the Atomic Energy Commission. This was referred to as Project Nova, or Nuclear Engine for Rocket Vehicle Application. This is where we got the basic design for the nuclear thermal rocket engine. They were actually building and testing prototypes of the Nova engine throughout the late 60s and early 70s with the idea of a human mission to Mars in mind. Unfortunately, in 1973, President Richard Nixon axed the whole project, and even though the engine has been deemed ready for integration into a spacecraft, they never made it into space. The idea sat idle until it was revived for the first time in 1983 as part of the Strategic Defense Initiative, or Star Wars program, and the nuclear engine project has come and gone from study ever since, never really being taken to full completion. Most recently, in 2019, US Congress approved $125 million for funding the development of a nuclear thermal propulsion rocket. So for the United States space program, it is something they are working on, but they are not exactly making fast progress over in Russia. On the other hand, they've got some stuff in the works, allegedly. Of course, it's Russia we're talking about, so they're kind of secretive and kind of sketchy at best. But the Russian space agency Roscosmos has this plan for nuclear powered spacecraft that would fly as far as Jupiter. Russia has already launched at least 13 nuclear reactors into space to test how they operate up there. The US has done this only once. In 1965, they launched a nuclear reactor-powered satellite called Snap 10 into orbit, but it stopped working after 43 days, and they never tried again. NASA has used nuclear power in some satellites and rovers, but these do not use a reactor. Don't ask me right now what the difference is, but there's a difference to be clear. These are just the reactors going into space. So far, none of them have been integrated into the rocket system. No one has actually tested a thermal nuclear engine in space, not that we know of at least. But back to this Russian nuclear spaceship. They call this Project Zeus, and they intend for it to be a kind of space tug that could transport people and supplies from the orbit of one planet to another. Zeus would use a 500 kilowatt nuclear reactor to travel from the moon to Venus, where it would use the planet's gravity to change course towards a final destination of Jupiter. This would be an uncrewed mission. Of course, Roscosmos estimates that the mission would last 50 months or a little over 4 years and could launch as nearly as 2030. The nuclear reactor on board Zeus is designed to last a period of 10 to 12 years, so in theory they could go much farther than Jupiter with this spaceship. This nuclear technology could also be the foundation of Russia's efforts to build a new space station in orbit around the Earth. We know that Russia plans to cut ties with the International Space Station and build their own by 2025, which is actually a very reasonable plan, as the current ISS is quite old and only has 10 or maybe 15 years left in its lifespan before it needs to be deorbited. A nuclear-powered space station could easily go so far beyond what we've been able to accomplish with the ISS that it's kind of insane to start thinking about. This is a game changer. We could actually have a full-blown modern research facility in space, not just that cramped-up solar-powered little series of tubes and boxes that we've been playing around in for the past 2 decades, if you want to talk about getting to the level of inhabiting space like in those O'Neill colonies that Jeff Bezos loves so much, then getting nuclear power working up there is how we do it. Same goes for settlements on the moon, and especially Mars, where solar energy will be reduced. Or what about settling on the moons of Jupiter? Nuclear power will make that at least possible, so this could clearly be a really big deal, and not very many people are talking about it. If we're thinking in terms of a space race here, then Russia seems to be winning when it comes to nuclear power in space, and that's not exactly great news for the rest of us. Russia doesn't really have a great track record of playing nicely with other countries, particularly the United States, so we're going to have to wait and see how all of that plays out, but we can imagine that there's going to be a fair share of political drama involved in terms of how safe this all is. It's actually pretty solid, as far as spaceflight goes at least. Nothing involving rocketry is ever going to be perfectly safe, but the point of these reactors is that they will only ever be activated out in space at a safe distance from the Earth's atmosphere. Even if there's a disaster during the rocket launches, say the whole thing just explodes while it's still within the atmosphere, the reactor will not melt down because there will be no nuclear reaction occurring at that point in the mission. The reactor will be shielded in a way that not only would prevent it from scattering little pieces of uranium all over the world if the rocket blew up, but it will also be shielded from radiating the crew of that rocket, though in reality the largest risk for radiation exposure to the crew would still come from the sun and the galaxy as a whole, and not the nuclear reactor under their feet. And that's why it also wouldn't matter that we're blowing a bunch of radioactive exhaust gas into space. It sounds like a bad thing, but space is already radioactive as all hell. We honestly can't make it any worse or cause any kind of harm to the environment out there. So that's the deal with nuclear power in space. It's pretty crazy stuff, right? Make sure to leave us a comment and let us know where you think a nuclear-powered space program could take us. Once you get the idea of how this works, it starts to feel like Mars is just a first step, and we can go much farther than that in probably much less time than we might have originally thought. But thanks for watching the video. Today we're still pretty new to this, so we really appreciate all of your support. Hitting that like button on the video really helps our channel to grow, and find new people. Leaving a comment is even better, and we really want to hear what you guys think of the latest space race news. So don't be shy if you want to learn more about the space race. We got 2 more videos up there on the screen for you. Please subscribe to our channel for weekly updates, and we'll see you in the next one.